Okay, so this lesson is on trigonometric identities. There will probably be more as the course goes on, but these are like the fundamental ones that will happen over and over and over again. Okay, and doesn't matter if we just which course we're doing, these are going to be really important. So one of the things we need to do is derive them and then learn them. Now, when I say learn them, is that we've got to learn to use them. It's really good if we actually remember them and learn them, but I will show you that they are in the formula sheet too. Okay, so these are the first ones, and these are all in the formula sheet, and we've sort of briefly talked about them, but the cosec is equal to the inverse of sine, and we've almost looked at this as well. And if we look at the third letter of each one of them, see how S, that means sine, C, that means cos, and T, that means tan, all right? And that's why when we look at the inverse of, when we go cosec, theta, we've learned it as hypotenuse over over opposite. It's because it's actually the reciprocal, the inverse of sine, okay? So that's the y. So we've got to write that down and understand it. Now, one of the most important ones, yet one of the most simple ones, is tan theta, is cos theta, is sine theta over cos theta. It's really important that we remember that, okay? Now, one value that cos can't be is when cos theta equals 0. So we're going to be looking at that more often, and that will happen periodically. So there'll be an asymptote every single time, okay? And just like that, cot is the inverse of tan, and so you'll see cos over sine. And that will become really, really, really important. So make sure you write these notes down, and yeah, we'll move on from there. Okay, so this is actually the most important one. And to do this one, I've got to build my unit circle, all right? So I'm going to pull my circle there, okay? And what I'm going to do is that, I'm going to put in a bit of details here. So this is x and this is y. And so I could write this down as x squared plus y squared equals r squared, because it's a circle, okay? It's a circle. So I need to understand that it is a circle, okay? And now I'm going to draw my line, and I know that this is r. And if I did this, remember I know that this is x and this is y. So this point here, so this is, I did it wrong. Let's get rid of that. Let's get rid of the x as well, because that's y and that's x, okay? So this point here should be x, y, okay? And here we have theta, all right? So instead of x, okay, I can write, so we go sine theta equals what? Opposite over hypotenuse. So it's going to be y over r, because that's the opposite here, and that's the hypotenuse here. Okay, so instead of, and I'll write something, cos theta equals adjacent over hypotenuse, so it's going to be x over r. So what I can do is I can actually make an identity with this. So clearly I can see that y equals r sine theta, okay? And here I can go x equals r sine theta, okay? So there's this identity that I can use, and I'm going to use it with this, improving this Pythagorean identity. I don't like that highlighter, so we're going to use this, okay? All right. Okay, so what we need to do is I'm going to use this guy and give us our, probably the most important trigonometric identity that we'll use in this course. So what I'm going to do is I'm going to divide both sides by r squared. So I'm going to divide by r squared, so that cancels out and that becomes 1. And then I need to divide every term by r squared. So what I get is I get x squared over r squared plus y squared over r squared equals 1, okay? Now that's our identity, all right? Now I can write this as x plus r squared, y over r squared, I think I said plus before, equals 1, okay? Now, what happens if I substitute instead of x over r, I put in cos theta. So that's what I'm going to do here. And instead of y over r, I'm going to put in sine theta. And that's what I'll do over here. Okay? Just so you know what I'm doing. So I'm going to draw a line here. And so we go therefore, and I'm going to put this in brackets. Cos theta squared plus sine theta squared equals 1. So all I've done is substituted this knowledge in, okay? And I know how to write this in trigonometry. I don't write it with brackets. I'm just going to go cos squared theta plus sine squared theta equals 1, okay? Really, really, really important identity, okay? So important that it's actually in your formula sheet. See, it's right here, okay? Now from that, we actually have 2 more identities, okay? So I'm going to use this, all right? I'm going to copy, paste, all right? And we're going to develop 2 more identities, all right? So I'm going to grab a different color pen. What I'm going to do is I'm going to divide both sides by sine squared theta. Okay. Now I know that the inverse of 1 over sine is cosec. So this is becoming cosec. Sec theta squared because it's squared. And sine over sine will be, so I'm looking at this one, will be 1 because they cancel each other out. Okay. And cos over sine, well, that's very similar. It was here. See how cos over sine is actually cot because it's the opposite of tan. So this one will be cot squared theta. Really important identity. Okay. Really important identity. And then from here, we can actually manipulate it. So I can write cosec squared theta equals cot. Yeah, well, that's what we have. Sorry. What I meant to say is that we can rearrange this, that cot squared theta is equal to cosec squared theta minus 1 just by moving this guy over there. All right. Okay, now the second one that we do is actually pretty much the same thing. So if we use this one again, okay, but instead of dividing by sine squared theta, I'm going to divide by cos squared theta, everything by cos squared theta. So cos squared theta, cos squared theta, cos squared theta. And because of the same reason as above, we're going to get 1 plus sine over cos is tan, so tan squared theta. And then 1 over cos is sec squared theta. Okay? So we have this value for tan. And likewise, I can keep going with it if I want to, is equal to sec squared theta minus 1. All right, just one more thing I want to say is a lot of these are in your formula sheet, so have a look out for that. We have these identities. I need you just to write them down. Okay, I can explain why they happen, but we just need to write it down for the moment. All right, that's the end of the lesson. Peace out.